Say shapes of objects, you can mathematics replace the shape of 40 of a pyramid, of a square. Are we together?
Yes.
Yeah?
Yes.
The challenge is when we are learning about mathematics or science, then we live life and then we learn about this stuff as something else new. Am I right? A tattoo? Tattoo is very surprised. Tattoo is saying, "Oh, sir, why didn't I meet you since my standard 3? That's what is going on in your mind. Why didn't you meet with this, actually, with this fact since standard 3? Even myself, I repented once I knew that. Because I realized that I've been lazy. Since standard 3. Because I done myself, I think that by that time I loved so much electronics when I was standard 3, standard 4, 5, 6. And I was growing up in the village place where there's no even the telecommunication towers or whatever. But I loved it, and I loved it through the radio. One day I'll share to you the testimony about how this business of electronics drove me since in childhood age. That's a very interesting testimony I will share to you. I don't know if you have one, or you found yourself that you did the application in TCU, and that's it, then you find you're in electronics engineering. Possibly. But I want to tell you that go back, ask God, because He's the one who knows. Is this your way? Right? Otherwise, you are doing somebody's business. You are doing somebody's purpose. Are we together? One day I'll talk about that. Then we are learning about terminology. Say terminologies.
Terminology.
Of electronics, say terminologies of electronics engineering.
Terminologies of electronics engineering.
So now the third terminology now is engineering. We are getting closer and closer and closer. I know that for you, you came, you're well prepared to deal about resistors, resistors, capacitors. Don't worry, we will get there. But I don't want to get there alone. I want to get there with you. And I want to get there with your mind. Because for you, I know that I want to know to build a circuit. Then, once you know that I want just to know to build this. Okay, it's not difficult, we can teach you. But how can I apply what you knew to solve a problem? That is another story. Are we together? Yes. And along your journey, you've been taught how to do things, but not how to apply them. You are being taught how to do things and how to use them to answer exams, and not how to apply them. So that has been left as a homework that you have never dealt with it. Isn't it? Yes. What do you think that now there's no any continuation for you in high level, maybe in undergraduate, just you have to be asked, okay, now let you apply the knowledge that you have. That to say, sir, don't say like that, it will be true. Okay, so now the fundamental question is, what is engineering? You know, one thing which I want to advise you, my dear student, before you learn anything, learn what does it mean. That's the strategy I have been using for more than 10 years. For more than 10 years in informal learning. Yesterday I told you that what I'm teaching you, almost 75% I learned it informally. I have an undergraduate degree of electronics engineering and telecommunication engineering. But actually what I'm teaching you, its contribution to maybe only 25%. Okay? Why? Because myself, I stopped it to complain. Right? Why did I stop to complain? I need the knowledge of practical electronics engineering. I have to find where it is. If it's not in the institutions that I'm studying, fine. I have to find where it is. I have to find it. That's my own ambition. I don't know about yours. Are you waiting for it to find you? Okay. Okay, what is engineering? Say, what is engineering? Say first, engineering.
Engineering.
What is engineering? You are studying engineering. You spent 4 months of learning about electronics engineering. What is engineering? What if somebody asks, what is engineering? In few words. It could be a difficult question, and you know that simply how are you going to reply? That questions do not appear in any exam. And they don't expect to appear in any exam. Because you are examination expert. That's the reasons. You are examination You study according to what is appearing what is. So tell your neighbor, are you examination expert? Ask him or ask him. Once you see he or she is smiling, then the answer is yes. Ask him, are you examination expert? Tatu. Ask it. If you will not ask it, we'll ask you. Okay, so I have found there are so many definitions or so many ways that you can define engineering. But I found one short and very interesting definitions of engineering according to Massachusetts Institute of Technology, or MIT. There's a professor there just provided a simple, powerful definitions of engineering. I have also some other definitions of engineering. I think I'll share to you too, because we are getting into the point now. So say engineering.
Engineering.
So what is engineering? These are the simple definitions you have to remember for the rest of your life. Engineering is purposeful use of science. That is purposeful use of what?
Science.
So now, you have been a good scientist for 11 years, or maybe for 9 years. Now you're in engineering. We expect you to use science on solving problems, but to use science purposeful. Say purposeful. Manake kwamba uhandisi ni matumizi ya science kimalengo au kimkakati. Sawa? Unatumiaje sasa mechanical nini? Mechanical science ambayo unaifahamu. Unatumiaje sasa kama electronic science unaifahamu. Unaitumiaje sasa maybe civil science ambayo unaifahamu. Unaitumiaje sasa labda nini? Computer science ambayo unayo. Are we together? Is a purposeful use of 40? Engineering is a purposeful use of 40?
Science.
Sasa hii reference utaulizwa nani alisema hivyo? Sababu bwana duniani kwa wanadamu tunauliza maswali mengi sana. So reference is MIT. MIT ni chuo cha kwanza cha uhandisi duniani. Sio cha kwanza kujengwa, cha kinacho yani kwamba kwenye ubora. Ni chuo cha kwanza bora duniani cha ufundi na teknolojia. Kirefu chake ni Massachusetts Institute of Technology. It's one of my favorite institutions. I learn a lot of stuff from them because they do digital teaching and analog physical teaching. Right? I don't know about you. It can be maybe Harvard, it can be somewhere else. It's fine. It can be Stanford University, it's fine. They are providing very useful contents, more than you think. Okay? Okay, so I don't know, what are you watching once you get in the internet? Maybe you're watching for what? Your TV. Or, are you watching your TV? TikTok, yeah? Okay. But again, I found another definitions from one website, very interesting, and I want to share with you. But let me share one. I think that I will share to you three because of how this part, or how this technology is important. I know maybe you have been like me. For myself, I think that for more than a semester, I was studying electronics engineering, electronics and telecommunication engineering, but I didn't know what the means of engineering. I think that for 1 or 2 semesters, even myself, I was in the same place where you are. And then once I asked myself, I said, so I'm learning electronics engineering. I don't know even what the means of engineering. Am I really serious?
No.
Yeah. So engineering is the application. Science is application. All of these informations, we need them in practical. Because the practical I'm going to teach you, I don't want just to teach you on how to do. I want you to use it. So engineering is applications of science. Say applications of science. So say engineering is applications of science. I say you are not Kingdom Moti Anthropoda or Kingdom Moti Animalia. You are Kingdom Moti?
Animalia.
Huh? So Kingdom Animalia always speak loudly, like me. So engineering is applications of science and mathematics. Say engineering is applications of science and mathematics.
Engineering is the application of science and mathematics.
Yesterday I told you why should you say, because once you pronounce, you are writing in your mind. Once you pronounce it several times, you are writing in your mind. And I gave you an example. Once you made with a complicated word in history that called Kinchekitile Ngwale, it wasn't easy for the first day to remember that name. But because you know it will appear in exam, you have to do practice. Kinje, 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 kiti, kinje. Hebu niangalie tena. Kinje kiti, kitile. And then Ngwale. Au mwene mutapa. Mwene mutapa kingdom. Or for example, can you tell me one phylum of kingdom plantae? Phylum what? Visnophyta. You see, it wasn't easy. For example, that the bacteria that cause malaria is called what? Anopheles. Is it a bacteria or what? That is mosquito, right? Plasmodium. Yes, I know you forgot them. It's not easy for you to be correct. But it's very interesting. But you remember that how were you struggling to write those information, a special classification. It was very interesting topic. Yeah? Those what we call it Greek words. And then in kingdom Arthropoda, there's a kingdom Arthropoda. One vocabulary that you remember. Isaiah. So you saw that, but whenever you pronounce it, you write it in your mind. Am I right?
Yes.
Yeah. But if you don't pronounce it, you will find in exam, you don't know how to pronounce, you forgot the word, the spelling of the word. Right? So the same scenario. Don't say that now I'm old enough. I'm no longer a Form 1. Okay. Sure, old enough. Okay, thank you. Okay. So it means that engineering is applications of science and mathematics to solve what? Solve what? Solve problems. While scientists, okay, so I think that I have to write this sentence. While scientists and inventors, come up with innovation, okay, innovation, it is an engineer, it's the responsibility of an engineer, Adrian, or engineer Tatu, or engineer Nancy. It is engineers who apply this innovation or discoveries to the real world. And I will give you one example that I learned from a professor of MIT in departments of electronics, of electrical engineering and computer science. He has been explaining the meaning of this sentence. Because having a sentence is something else and its meaning is something else. So he said that I would say scientists and innovators come up with innovations. Say innovations.
Innovations.
So it means add something. Add something new. Right? Add something new. comes up with such innovations. And then it's engineers who apply the innovations or discoveries to the real world. You understand that phrase? Maybe you don't understand. But let me challenge you. Let me challenge you. For example, I give you a lamp like this, right? And I ask you that, imagine I connected this lamp, maybe this because you have the C lamp and the AC lamp, right? Are you together?
Yes.
So suppose that this is the DC lamp, right? Then I ask you to connect it to power, maybe to the battery, a battery of 9 volt, maybe it is 12 volt. Most of the DC lamps are 12 volt. Suppose that this is the battery of 12 volt, right? So I give you its wires, and then I ask you to turn it on. Okay? Once you turn it on, then I ask you to calculate the current flowing through this lamp. So I want now to challenge you, the mind of the scientist and the mind of the engineer. Are you ready for that? No, you are not ready. You are not ready. You say that you know it. So here is scientist. We have so many scientists here. We have so many science students. Here is the mind of scientist. Here is the mind of the engineer. And suppose that this is electrical engineer because the lamp it's electrical component. So scientist, electrical engineer. Then both of them you gave a responsibility to calculate the current flowing through the lamp, right? Hopefully they can draw the circuit. Okay? So maybe we have the circuit and here is the lamp. I don't think if they need a resistor, but maybe they can need a switch. It's the on-off switch. Here it's a battery. Then these are the wires. Okay? So this is the example. Gilly, you are busy with something. Okay? So this here it is 12 volt. This is the switch. We use K for switching. These are the wires. Right? Are you together? Okay, so suppose that this is figure 1. Again, here we have electrical engineering. Most of them have been given an assignment to calculate electric current flowing through the lamp. So this is the switch. This is the battery. 12 volt. Want to challenge you, show you the difference between us engineers and scientists. Where should you think differently? It's the switch case. But you find sometimes you graduate and you are neither scientist, you are not neither scientist nor what? Engineer. It happens. Okay? Okay, so listen. So once you turn it on, it's not time for drawing. Listen first to understand. Understand first. You have been writing so many information. How many counter books do you have at home that you have written yourself? And what do you still have in your mind? You have written much more than what you have in your... Why? Because maybe by that time you like writing. You didn't attend the previous session like my sister there, Gil. Then she came, give me the notes of yesterday. It's not. You're a good writer. Then I will study it later on. Not today, later on. And I will study it when there is an exam. Because I know some questions can appear from there. If there's no an exam, okay, one day, when I don't have any activity, I can go through it. And that one day, it will be so many years. Okay, so once you turn this switch on, then there's the flow of electric current, right? Where the directions of current, this is the directions of what? Of current. Suppose this is current 1, and this is what? Let's say this is figure 2. Figure 1.2, this is figure 1.1. Also, once you turn it, it means that you close this switch, then the electric current will flow through the lamp. Let's say this is current 2. So this is still current 2. This is just the number. This is current 1. All together. The responsibility we've been given are the scientists to calculate the current flowing through this lamp. L stands for lamp, right?
Yes.
And then the responsibility that the electric engineer has been given to calculate electric current flowing through what? The lamp. Right? So listen now. So the engineer, the scientist, will need some inputs first before calculating the current flowing through what? A lamp. You know what are the inputs? First of all, a scientist will ask you that what the weight of that lamp, because weight matters in science. In engineering, sometimes we ignore it, right? Weight of what? Weight of lamp. This is the scientist, right? And then scientist will ask you that what the thickness or what the size of the lamp. Then also scientist will ask you that what the color of the lamp, because color matters in science. Are we together? Then the scientist will ask you that what the texture. Is it rough or not rough? Then a scientist will ask you that what the dimension of that lamp. And then a scientist also can ask you that what is the resistance against the flow of what? Of electric current. And then a scientist can ask you that what the voltage applied, etc., 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 etc. Then once a scientist have all of those inputs, you will find an equation which relating all of this, and now it can give you the current. Hamjanielewa? Tanielewa. Ila hii ni kitu kizuri sana. You know now, the engineer, nitarudia pale. Sababu kuna wengine wanasema yani sawa mkirudia. Hata nianza kuelewa afu imepotea tu hapo. Okay. So now the electric or electronic engineer, actually that in order to calculate current 2, he will need only two inputs. Then he computes the current flowing there. Why? Because in engineering, we have to make abstractions or assumptions in order to design interesting systems. Oh. So an engineer will ask you that, what the resistance of the lamp? If the resistance of the lamp is not known, then he will use what? Ohmmeter to measure it. Right? So what the resistance of the lamp? Then the second piece of information, what the voltage across the lamp? What the voltage supply? Voltage what? Oh, voltage what? Voltage supply. Only these informations are important, are required for the engineer to compute the current flowing through the lamp. And then now the engineer will tell you there are the scientists who did innovations on what? On relating the voltage and resistance, whose name is Ohm, and we as engineers will have to take that innovations and design lamps, which are electric engineering lamps, that can solve the problems of darkness. So Ohms told us, wonderful, compute current, so this is current 2, so it will be voltage supply of a resistance. While the scientist will have a big equation that's computing current 1. Maybe you can find, maybe, it's not like that one's maybe. You have your weight, maybe weight square, you have your maybe sizing. So size maybe sizing, you have your color, maybe you have a square root of 40, square root of texture, and then you have 40, maybe square root of 40 of dimension cubic. Are we together? So it means that he needs all of this information to plug them to computing current 1. And from there, that's only for the lamp. The scientists will need all of those information for everything. So, would you think that how are you going to apply that knowledge to solve a real life problem? Because once he finds that the currency is not maybe the one expected, he has to adjust to change the weight, or maybe to change the size, to change the color. Until you die, that lamp is not practically applied, because some adjustments are still being done. Are we together?
Yes.
Did you understand such kind of example?
Yes.
So these guys, they are designing, actually they are innovating, but we as engineers, we have a responsibility to understand what they have innovated. And you have to understand what is required in the real life, okay? In the human life or in the real life. And then we have to match and to see how we do assumptions. So engineering is all about assumptions and building abstractions of abstractions in order to build a very interesting system to solve mankind problems. Are we together?
Yes.
Kumbuka tu ni najibu swali, what is engineering? Ambalo wewe nilikupa jana, kaenda, Google, kafanyaje. Lakini tulikuwa tunafikiri tofauti Etinance, yani ulichokitafuta jana. Ulitafuta hivi? Sikuwa sema huyu mwalimu kweli hanijui mimi kama na yeye ya physics. Hivi mwalimu hivi kweli anajua kwamba na banda la advanced physics? Au anajua kwamba na banda labda na nini? Hivi anajua kweli au ni text